This is a short video showing how to draw Lewis structures using a system or series of steps. Let's take SF4 for example and figure out how to draw a valid Lewis structure. We'll also do the same thing for ozone, and we're going to do it in steps. First of all is to count the valence electrons. So for sulfur we know there are 6 valence electrons. For fluorine there are 7. But we have to times it by 4 because there are 4 of them. So we would add that together and we would get, since 7 times 4 is 28, plus the 6 is 34 electrons. That's the first thing to do, is to determine the number of valence electrons. We could do the same thing for ozone. Ozone of course has 6, oxygen in ozone has 6 times 3. We'd have 18 electrons. The second thing to do is then to make a frame that we can build off of, wherein the central atom is the one that has the greatest need for bonding, is least electronegative, or is a third row element and below, trying to meet all of those conditions. So sulfur is needing 2 bonds at least to get to the octet state. Fluorine only needs 1. So on that it would be the central atom. The second, we notice it's also a third row element. Sulfur is in the third row just below oxygen. So we're going to put sulfur in the middle. Now it's kind of obvious it's the central one because there are 4 fluorines. Let's do the same thing for ozone. Well, this one's easy. We know this has to be the base frame from which we build our valid Lewis structure. The third thing we have to do now is to add in electrons. So I'm going to go ahead and do that on this frame we've built. We need to add in 34 electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Now I'm going to count the bonds. We have 26, 28, 30, 32. We notice that we need to have 2 more electrons added in. So I've put them on the central atom because fluorine, being a second row element, can only have 8 electrons at most around it. Sulfur is a third row element, so it can handle more than 8 electrons around it. It has the ability to use d orbitals along with p's and s orbitals mixed together to hold the electrons. Now we've added all the electrons in, we need to check the charge. Because what we want to do is to minimize the charge and achieve the octet state for second row elements. So we notice the charge for fluorines here, being that they only have 1 bond, which is what they desire, they're neutral. Sulfur, we want to probably use the formal charge rules and to take the number of valence electrons, 4 bonds off of the sulfur. We can subtract the number of bonds from the electrons that it had going into the structure. As an atom, this 6 is associated with the number of valence electrons that sulfur has going into bonding, going into a structure. So 6 minus 4 bonds minus the 2 electrons that it owns as a lone pair is equal to 0. So we would be done with this structure. This would be the valid Lewis structure. Now let's go ahead and add in our electrons, the 18 electrons on this frame we have here. From the outside in, so I'm going to do the outside first. If I total this up, that's 6 plus 6 is 12, 14, 16. Now I'm going to have to then put electrons on the central oxygen because I've completely exhausted the ability to go to the outside. So now I have 18 electrons. Now notice that this oxygen and this oxygen, if we leave it with only 1 bond, would have a negative charge. In general, oxygens and nitrogens, if they have less than the desired bonds, they're negative, and if they have more, they're positive. But we can use the formal charge rules. we know that for oxygen, oxygen has 6 electrons minus, let's just take this oxygen and look at its formal charge. It would be 6 minus 1 bond minus 6 electrons that it owns. So the valence electrons, the bonds, 1, and then the valence electrons were subtracted from 6. 6 minus 1, because this oxygen had just 1 bond off of it. This oxygen had 6 dots off of it. Those are the, not valence electrons, but lone pair electrons. So 6 minus 1 minus 6 would be equal to minus 1. This would have a negative 1 charge. Negative 1 charge. We don't want to leave charge on these oxygens, and we even have a further problem. This oxygen would have a plus 2 charge, because 6 minus 2 is 2. So we want to minimize charge. So what we're going to do, we've determined the frame, we've added the electrons in, we've determined the charge, is drop down electrons if we can. And we can do that. If we can drop down, we want to. Now we couldn't do it here because there was no room, or there was no need to drop electrons down. These were all neutral. But these are not neutral. The fluorine does not have formal charges up here. These oxygens do. So we're going to drop 2 electrons down from the oxygen that were owned as a lone pair to a pi bond. Now I can do it one of 2 ways. So I'm going to go ahead and draw both. And a resonance form, a valid structure that looks just like this but is using the oxygen on the other side. We then would have the negative charge for this oxygen remaining. This oxygen will now have a plus 1 charge because we gave it 2 electrons, and you can find through formal charge calculations this oxygen would be plus 1. And of course over here we'd still have plus 1, minus 1. And we're done. Because we can't put any more down. If we tried to go further to get rid of this charge, it would put too many electrons around the oxygen. He would have 2, 4, 6, 8, and we cannot bring more down. So let me review the steps we took. We determined the valence electrons. That's number 1. We drew a frame where sulfur was in the middle of 4 fluorines. We then took the 34 electrons and put them in from the outside in, and then we had to put 2 electrons on the sulfur because we needed to get to 34. And once we made it to this, we checked our charge, and everybody was happy for this structure. So we didn't need to drop down any electrons or move anything within what we had as a starting point. We were done. But here, as a starting point, when we checked our charge, we did have charge on this oxygen, and this oxygen, plus minus 1, plus 2, and minus 1. So we dropped down to satisfy the charge on this oxygen, make it neutral, and also to satisfy the desire of this oxygen to achieve the octet state. But once we did that, we could no longer drop any electrons down on the central element. I hope that helps. Hope you have fun trying this with some other structures. Bye-bye.